Video on average atomic mass. So on the periodic table, we have all of these elements, and you will see that I'm going to actually take a look at copper here. We're going to use copper as an example today. Copper has this value on here, and that value, these numbers are the atomic mass or the average atomic mass. And so for copper, it's 63.55. So where does this number come from? Where does this value come from that's automatically on the periodic table? We use it all the time, but we want to know where it comes from. And so how do we determine this average atomic mass? Well, we're going to do a couple of different steps. The first one is we need to know about all of the different isotopes and their mass, and then the relative abundance that we have of them. So we're going to then add the products from that up. So we take all of these isotopes times their abundance, and we want to change it from a percent to a decimal. And then we're going to be able to get that value in atomic mass units, or AMU. If we're looking at a whole mole of substance, like we will later on in the year, we'll take a look at that value in grams. But for right now, we're going to use AMU. So here's an example, and like I said, we talked about copper. So this is the mass and abundance of copper isotopes, and this is one way we could see the data. And so we see this is in percent, and we want to change percent into a decimal. And so to go from a percent to a decimal, there's two ways to go about this. Either you can divide by 100, or you can just move your decimal place 2 places to the left. And so that's what I'm going to do. So the first isotope of copper that we have is copper 63. And so we see that the mass, the AMU, is close to 63, not exactly. And our percent we want, or our decimal we want to change, our percent we want to change into a decimal. So we're going to move that decimal 2 places over, and I can rewrite that as 0.6917. And we're going to multiply these by each other. So let me go ahead and bring up my calculator and get that added in here. Oops. There we go. And so I'm going to do 62.93 times our 0.6917, and I get 43.528. And we'll call that 7. I'm going to go ahead and write down some extra numbers, but it's nice when I just have these numbers in my calculator. We don't want to have rounding errors. So always maintain some extra values. All right, so for copper 65, we do the same thing. Move that decimal place 2 places to the left. We're going to multiply, and so that gives us 64.93 times 0.3083. And I get 20.0179. Now be very careful. The biggest mistake I see here is that we change the wrong thing to be a decimal. So make sure it's always the abundance. All right, now that I've done that, my last step is to go ahead and add these two values together. So I'm going to add these values together. So I'm just going to go ahead and go plus, and we'll do our 43.5287. Oops, I forgot a decimal in there. And I end up getting 63.55 AMU. Now, since our values for mass were 2 places right of the decimal before, I'm going to go ahead and maintain that 2 place values right of the decimal on this. We will talk a little more specifically about how we round things later on. So that's one way we can take a look at the data. Another way is to actually see it with something like this, where we have a graph. And so in this case, it's quite interesting. Our values for our mass numbers of our isotopes are actually rounded numbers. They aren't those exact numbers. So we're going to get close, but not exactly with this one because we're going to be in the ballpark without that exact number. And then we have our percent abundance along the side. And so I went ahead and put the percent abundance values up here just so it would be a little easier to read. Otherwise, if you didn't have that, you would have to guesstimate approximately what that would be. So for magnesium then, we would do the same thing we did before, and we're going to go and do our 24, and we're going to multiply that times 0.7899, and then we're going to do the same thing. So 25 times 0.1000, and then 26 times 11 point, change that to a decimal. See, I don't want to forget that. 1101. I always forget all the simple things that I should remember. All right, so let's go ahead and do these values. We'll get these values. So 24 times 0.7899 gives us 18.9576. 25 times 0.1, of course, is just going to be 2.5. If you're like me, I love to see that number in the calculator just to make myself feel better. My mental math is sometimes a little lacking. And then 26 times 0.1101. That I can't do in my head without a lot of effort. 8626. Okay, so again, we're going to add those values up. And I've already done that, so I'm just going to go ahead and write down what the value is. I got 24.32 AMU, which is really close. I think on our periodic table it's 24.31, and so we're very close to that actual value. I hope that was helpful in you understanding how to determine average